Good afternoon. How are you? I need to apologize for something. There's a bit of incompatibility between my laptop and the projector. So the word Lego is actually yellow highlighted. So please bear in mind because I have plenty of yellow text highlights in my slides. So thank you so much for joining me for this session. You know what? Usually when I see my talk scheduled for the last final session or towards the end of the final day of a conference, I come prepared with a few jokes because I want everyone to be here until the end because I'm always in a hurry to get the bus or get to the airport and things like that. But today I haven't because few reasons. It's an amazing conference, organized so very well, and great place and nice weather. Of course, I've come from London, so I know that. And the other reason is it's a weekend, so we are all relaxed, not in a hurry. And the third most important point is, unusual to a conference, we have a bar at the last day of a conference. So that opens after the session's over. So we have plenty of good things to look forward. So here we go. So my name is Sheen Brisals, and I work for the Lego Group. I'm based in London, and I'm part of the engineering team. And so what I'm going to talk today is basically about our experience of moving to serverless. So, and how we did that and how we are kind of continuing on the momentum that we had, how the team's kind of progressing on the development. And because my involvement with the serverless community, I talk a lot about serverless, I write about it, and be on social media. I have the humble recognition of as a serverless hero by AWS. So I'm an AWS hero for that, for that matter. So this is lego.com, the landing page. One thing I want to clarify before I get going is because people often ask when I say I work for the Lego Group and talk about serverless, they think that everything in Lego Group is on serverless. No, that's not true. So if I give you a quick run through of the organization, so I belong to the highlighted part of the org chart. So we have a big digital tech organization that has multiple big departments, and I come under what we call the marketing channels technology, or MCT, which has multiple domains, and at each domain we have number of product squads operating or developing. So predominantly most of these squads use serverless in some shape or form. Some squads are heavily into serverless, some are full stack, bit of backend serverless, front end. Others work with third parties, so they use for integration purpose and things like that. Across Lego Group, you will find all sorts of technology. So you will have containers, Kubernetes, legacy SAP, big monolith applications, all sorts of things you will find. So today's agenda is I will talk briefly about what and why of serverless, and then I will go through our experience, decision to go serverless, and certain guardrails and principles, and how we kind of set up the development structure for engineers to work on. And then I will finish off with serverless as a new technology is always evolving. So how can we keep up with such a modern technology? So I'll close my talk at that point. So what is and why serverless? How many of you are familiar or doing something or production workload, etc. on serverless? Okay, quite a few. That's good. So what is serverless? It's a typical kind of definition. So it's a cloud computing model. You have no server management, and then all the good things. So you pay for compute, so you don't kind of pay for idle, except probably for storage, and all the things like auto scale to zero, and low cost, all sorts of things. But for me, the most important thing is why serverless? Why do we need serverless? This is because often people think that serverless is just cloud functions or the Lambda functions or the Azure functions. No, it's not. It's an ecosystem of multiple managed services coming together to provide a solution. So that is an important point to remember when we talk about serverless. The second important aspect is because it gives us the granular control to play with, we can optimize things deeply. I talk about this sort of granularity principle is because if you have two different functions, you can tune them differently. two queues, you can optimize them as you wish. Same with tables and things. So we no longer kind of optimizing as a container level or a big box level, but rather we are going deep down to the granular level and tuning as we need. So that's an important aspect of serverless, in my opinion. And that also comes with the deeper level security. You can kind of tie down your data tables and data stores accordingly, encrypt and all sorts of things. And it's a perfect tool for iterative development. You don't need to go with the big bang development stuff. You can sort of go with the smaller increments. I'll talk about that more on that later. Another important aspect I always stress on is it brings the engineering diversity to a team or the organization. What do I mean by that is like we are not kind of just programmers these days when we work with cloud or serverless. We need to understand how to secure your functions or how to secure your resources. We need to understand how to, queue things to smoothen, your workload. So you need to understand how to put up your deployment pipeline, how to look after your workload. So all these aspects are now part of the kind of the engineering team. We no longer have these sort of siloed things that we push over the wall for somebody else to take care. It's all part of the development team or the product team. It's a responsibility. So that's why I say that it brings the engineering diversity into the team and into an organization. So what made us to go to serverless? So this is the old legacy platform, a typical monolith. You see on the right-hand side, you have the Oracle ATG e-commerce platform. And this is not sort of the modern cloud API gateway. This is a different product. But thing is, those days, deploying something to production is a big occasion. So we need to kind of split that into two pools. And then each pool, we need to go through this sort of the ceremony, like, drain the traffic and do the deployment, test it, et cetera, et cetera. If any of those steps fail, we all go back, to the back, all to the, the back. So typically, if everything goes smooth, it takes 2 to 3 hours for a couple of engineers to collaborate. And on a bad day, if something goes wrong, it takes, longer. So, and these things don't happen. These are rare occasions, like once in few weeks or once in few months. And again, when you get to, the season like this, the end of the festive season, it's a code freeze. No, you can't touch anything. And it stays until, January. So these sort of the struggles that we've been through. And on the other hand, the products were getting popular. We were getting more and more traffic coming to the platform. So we were struggling to cope with the incoming traffic and the spikes. So typically, any Black Friday used to be a huge struggle. But then one day, it happened that as the traffic peaked, within few seconds, one by one, these systems went down. We had no clue, no control how to stop. And that means within 15 or 20 seconds, we were serving this to customers. So that became the final straw or the last straw, the turning point for us to look something different. The reason, I shared this picture millions of times, but the reason I put this up here is for the next slide. If you think of all the the failure points in this architecture or in this monolithic system, it becomes very evident because the tight coupling, the constraints of the scaling aspects, and everything else. So one big database that is struggling to cope with everything else, and the limited thread pool and connections and all sorts of things really caused the trouble and restricted us kind of opening up new adding new features or going to few new markets. On the other hand, the business demands were growing all the time, so they wanted to expand to different locales or markets, and then they wanted to have these sort of newer ideas coming into because you hear in the industry, people are doing DevOps and they're doing great velocity and all sorts of things. And in terms of product development, you hear about the MVP. So that is the minimum viable product. What we need is another MVP, which is the maximum valuable. How can you transition your the minimum viable to a maximum valuable product. So these sort of things were, part of the discussion. And another important aspect was the observability. Business wanted to know exactly what happens where. It's not good that you only give the whole entire box view. They want to know which functionality, performs well, where the customers are hitting hard, where are the struggles, etc., etc. So all these kind of things mattered. So change was inevitable. But the problem was, where do we start? So we had options, too many options, for example. So shall we go for off-the-shelf solution? Then the problem is that you kind of queue up to them asking for every new feature you want to add. The other option we had was like the provider we were using, they were offering their kind of cloud version. But in fact, it wasn't just a cloud, it's just a wrapper and named as cloud. So that was another one. Then we thought, okay, microservices. Everyone is talking about microservices. This is back in 2016, 2017. It was good. So, but those days, mostly Docker, containers, and those sort of things. But then someone said, isn't that exactly what we are trying to avoid? We don't want to manage containers, and we don't want to scale things manually for ourselves. So with all these things, we went out to different conferences and spoke to different people. And in London, we used to have plenty of meetups, evening meetups, where you can just go in and talk to fellow engineers and others coming from the industry. So that's how the serverless thought came in. But everything was new. So we had one or two references where people were doing it successfully, but still early days. But we had to make a start, okay, because the time was running out. So the first step happens. I like this, code for many reasons, because everything starts with a single, simple step. If you go for a walk or running or whatever, but even when we break down big monolithic complex systems, you need to make a small entry point to go from there. So that's why it's important for me. So what we did was we tried one simple microservice. So this is all in AWS. So what we did was to smoothen the load on the tax system, we put up one API endpoint backed with a Lambda function. Okay, so that's what we did, and that went to production, and it stood up to a Black Friday beautifully. So that gave business confidence that, okay, so this technology these guys were talking about, maybe it's good. Maybe we can try something, on top of it. So that's how kind of the whole thing kicked off. I always say that if you are kind of thinking of doing serverless, think that, keep in mind that nobody is doing it perfectly when they make a start. But the important point is, as you progress, try to make it better in every iteration. Otherwise, you will get into a complicated situation, then you will start hating serverless. So that's an important aspect. So usually when we look in the industry adoption, I see two patterns. On one side, we have the sort of the speedy adoption camp. What they do is they look at the technology, they identify the simple entry points, they look at the patterns. Okay, so let's make a start and then grow from here. All the kind of the good agile and iterative patterns. The thing is, they kind of race ahead in competition. Whereas on the other camp, what I call is endless experimentation. These are the companies, they are so judgmental, and they think of all sorts of things. Even before they understood the technology, they wanted to write, documentation and this and that. But if you convince them with everything, but then there will be a clever guy at the corner will be asking, oh, what about vendor lock-in? Oh, vendor lock-in. So that fear comes down. They go back to the drawing board. So they never make a start. The thing is, in a competitive world, when we are kind of up against a competition, bringing out products left and right center, we need to be up there with the technology and the attitude to bring value to the business. Otherwise, we will lose, too soon in the current world. So speed was an issue. But speed is a generic term. The rich man once said, speed matters in business. But how do you define speed? If you walk 100 kilometers, that is speed. I am, riding my bike, that is probably 10 or 15 kilometers. I say that is fast. I am walking fast. So we can't kind of, clearly defined speed unless we know what we are trying to get to. So what we did was we had 10 months to do this work. So we said, okay, let's say 100 kilometers per hour is a reasonably fast speed. We need to hit that quickly and keep it going for 10 months, no stop. So that was the deadline, because otherwise, the renewal contract and the cost and things like that is so much. So we didn't have an option. So to put a different way, so think of it's you are about to take off. You hear the pilot announcing crew ready for takeoff. So that's the stage you're there. Then it's just one-way traffic. You hit the speed bar, and when you reach the other end, there is no other option to under takeoff, because you can't just abort at the end, right? So this was the situation we were put in. And luckily we had a sort of a project name called honey badger. So this animal, honey badger, I was told that its characteristics, like when it runs, if anything comes in between, it will just smash and go forward. So that was kind of the attitude we had to have in the team when we were doing this work. Anyway, so things moved on. So this was the team when we had at that time, a small team, because that was the time when the Lego.com, within Lego Group, we were trying to build the team, trying to bring work back from the external consultants into the team. And as I said, this happened, the first one. Then the first ever serverless event-driven architecture we developed was this one. Now, I'm not going to go through the details, but back in those days, doing serverless and seeing this sort of architecture, anyone will question how the hell is going to work, because you have a data store, something dropped in, it kicks off another function, you put into another queue, and another function comes in, and then finally you update somebody else's platform, okay? But interestingly, it outperformed the old platform. And that, again, kind of giving us more kind of, courage or confidence in the technology, that if we kind of do it properly, we may be able to hit it. So these were the little kind of victories that we had. So from there on, we moved on. We quickly kind of developed more data pipelines. So we had now like a 15 or 18 pipelines. In doing so, there are two important, software engineering patterns here. Okay? Can anyone tell me the pattern? The first pattern is copy-paste, right? So you have one in place, then you replicate. The second one, obviously, is copy-paste, update, or edit. So jokes apart, what we learned from here, we were able to tune, the granularity I mentioned earlier, each pipeline as we needed. Because certain updates, like pricing, for example, it should go fast. So we were able to tune the queues and the functions accordingly. Whereas if you have, say, product review feeds, so there we could play around with a bit of a time. So these were the little kind of learnings the team made as we kind of, progress with these things. And then soon after, we had to put up with the event ingestion. So this is a clickstream event ingestion. As you must be familiar, if you visit any website these days, you are tracked behind the scenes, wherever you click, which page you visited, which product you looked at, all sorts of things. The data is used for business insights and also to give you product recommendations. So in here, we are, faced with hundreds of millions of events coming through. So we had that pipeline in place, and we have the architecture in place. It's still working, so still in place, the same thing. And again, moved on. So beyond the architectural diagrams I show there, what I'm trying to focus here is the sort of learnings that we picked up from our early days. So this kind of grew. And when we faced with the situation of customer data migration, typically when you move from your legacy to a modern platform, you will be faced with this challenge, right? How am I going to migrate tens of millions of customer data from this system to this one? You obviously kind of, sometimes you employ people to do on the data migration, etc. What we did was, we took a risk. We said, we're not doing migration because some part of the data will be kind of completely obsolete. Customers would have created new profiles and all sorts of things. Instead, what we did was, we trusted on the event-driven architecture. We said, first time when a customer comes to a new website, We will do some event-driven magic behind the scenes to pull the data from different systems, and we'll update the new platform. So that kind of worked beautifully. So we only have, sort of few milliseconds before this to happen. So that again, proved that the serverless kind of journey is going in, good direction. And then finally, the most important checkout services happen. So again, learnings from here. So this proved the point that serverless, the front end backed with the serverless microservice is good enough to client-facing, user-facing actions. So typically, people don't think that serverless is good for these things. They think, oh, it's good for some sort of, back-end task and batch jobs and things like that. So here, if you visit Lego.com, if you drop, pick product and drop to the basket, and you go through the checkout process, you make your payment confirmation, or behind the scenes, everything is handled by serverless microservices. So that kind of enabled us to move to serverless back in 2019. Okay, so we operate on AWS, and if you look at very high-level architecture, the right-hand part, that's 100% 100% serverless. We don't have any servers at all in that part. The front end is on, Fargate and those sort of technology. There's a GraphQL layer, and the front end is typically, the JavaScript, React, all sorts of things. Okay, so what did we gain from that? So basically the growth. So I often say that, as I was explaining, that technology like serverless, it takes a while to kind of, to get it lifted off. But once you did your hard work, once you kind of, went through the pain, then it becomes so much easier for you to carry on from that success and kind of more like, sort of snowballing effect that you gain more and more traction. So that's an important aspect when we work with, serverless. Okay, so business growth wise, as I mentioned, the struggle we had with, the high sale events. So it became more like a usual activity. We kind of no longer track things. So every Black Friday or product launch, to be honest, I think last night we must have launched quite a few products, so must have seen spikes in traffic and things like that. So normally in these situations, for the serverless side, we don't do anything at all. I mean, that's not typically, exactly true, because what we do something. We do sometimes keep what we call the provision concurrency for certain functions. So that means those functions, number of functions or instances will be ready in a very high, sale volume events. Otherwise, they just perform. So these sort of the typical spikes, like the vertical spikes or the fountain spikes that we usually see on occasion. So you just handle, beautifully, so we don't need to kind of, do anything. In terms of team growth, I mentioned we started off very small, and by the time when we finished the, the migration work, we had this setup. So typically the front end and the back end, the team. The back end at that time was like, the serverless services team. And then from there on, things moved on very fast, because though the initial focus was on Lego.com, based on the success, the many other teams and product developments around that started to evolve. So things like customer support and more analytics and loyalty-related programs and all sorts of things. We don't usually see upfront, but they're all behind the scenes. So that started to happen. It's still, kind of growing. So this is summer. So we have so many product teams now. When I say product teams, typically if you are familiar with this sort of a Spotify model, so that's kind of the typical, 7 to 9 people. So every product squad has a, product purpose, obviously. Then a product manager, engineering manager, or a lead engineer, and other engineers, QA engineers. It's part of the team. They're not kind of, not someone, the good old siloed model. So they're all within a, setup. So we have number of microservices. I'll talk about what our definition of microservices soon. But how did we do that? So certain principles and guardrails, because as I mentioned, there are many things when you talk about serverless. What we did was early days, we didn't allow that much of flexibility for the early teams to kind of, experiment. For example, we said we will use serverless framework. That's it. We are not going to experiment anything else. And we will use, because this is based on the, the data we collected, we said we use the Node.js. And that helped because we had front-end engineers familiar with Java. There's no point in kind of bringing in Go or something else and complicating matter. And now we have a bit more flexibility and freedom, but those days, those kind of things help to keep that thing in check. And the sort of solution design, I will talk about them briefly soon, and the following of the event-driven architecture, that really helping even now for us to kind of decouple and identify which one to be synchronous, which one can be async, and that kind of helps with the development team. And iterative and incremental approach, I can't stress enough. So this mentality of kind of starting small and evolving and going in small iterations. And one of the things that often teams struggle with is to come to a conclusion or a solution when they review designs or architecture and things like that. So it's always important that keep that minimum. Okay, if you think that it's so complicated and things, try to find the simplest option, simplest area to make a start, and from there to grow. Otherwise, we will never make a start and kind of delaying things unnecessarily. And the autonomous product code I just mentioned. So typically, they kind of own their product. And obviously, they have the domain boundaries and contracts and things. And it really helps in terms of gaining the velocity or momentum for the teams because they are kind of focused on their own product area. They have their own repository and the accounts and things like that. So speaking of cloud account separation, so another benefit is like you can have different product squads operating on their own cloud accounts. I think it's going away now, but still there are teams they use a single account and tag to differentiate their dev, QA, and prod. Just don't do it. Keep separate account because it doesn't matter. As far as the cloud provider is concerned, all these things are the same configuration, same setup. It's just us calling us prod and obviously kind of restricting few things. But typically the olden days, when we have the prod, that gives the God status, whereas the dev and the QAs got kind of downgraded with the resources and stuff we supply. But these days we don't need to because everything is kind of the same setup. And the other thing is like that also allows certain product squads to have different accounts. Sometimes they have a sandbox account or a UAT account. So that kind of flexibility allows. But when I say these accounts, so in an organization, if you're familiar with AWS, you have the organization at the top and there are policies and things will flow down. So when teams go to the central platform team to provision for an account, so obviously they get a bunch of these sort of policies and constraints coming down. But once they got their account, it's up to them to, they operate that. Serverless patterns is, and again, there are a bunch of patterns. If you are into serverless, you must be familiar. If not, look at the places where serverless land, and I'm sure the other cloud providers also have a bunch of things. The difference is like we have the good old gang of four patterns and so many other things, but not necessarily we can apply all those old style patterns onto serverless and modern cloud. So we should be prepared to kind of transform or transition or change our mindset accordingly, rather than trying to fit an old pattern with a modern technology. So that's another important aspect to keep in mind. Automation, obviously, I don't need to talk too much. So CI/CD pipelines and DevOps culture. So DevOps culture, I think I heard one or two talks earlier talking about this. Is an important thing because, like I mentioned earlier on, the engineers' diversity, they now become part of the whole journey. Okay, so they now know how to set up a CI/CD pipeline, whether they use Circle C or a GitHub, actions and things like that. So these are all part of them. So they are kind of becoming DevOps. So one of the things that we recommend engineers is like when they bring up a new feature, as part of the, beyond the solution design, et cetera, when they set up tickets and stuff, they should have tickets to set up the observability side of things, the monitoring dashboard. It's them, they are, who set up the dashboards and stuff, not somebody else from the platform team helping out. And practices, I mentioned solution design. I mean, we insist on solution design for a number of reasons, because that allows the clarity in the solution they are proposing. Okay, and I wrote a couple of blog posts on the same thing. So the process is like that. So when a feature comes for development, so kind of quickly do a brainstorm, and then we identify engineers to own that, so the design. So one or two engineers, depending on the scope of the work, they will own, and they then interact with experts, etc., to come up with the initial draft solution design that will include architecture, data modeling, event schema, etc., etc. So that then get to the review with the team, and sort of the questions and challenges and things that gets iterated, refined. Before it's okayed by everyone, then they start creating stories, and then gets into the development implementation. So security and threat modeling is an important aspect. So even though we get a bunch of these things by the cloud providers, it's still very important. Like the GDPR and data visibility, these are important aspects that we need to kind of bring up to the teams. So most part of this data privacy and threat modeling is creating the awareness to the engineers, because not everyone comes from that background. So we need to kind of bring this sort of knowledge to them. So when we have this sort of threat modeling process or something, that's what they learn, the new engineers from others. So we follow the stride, and we produce documents. Again, it depends. Certain solution designs don't require a full length threat modeling exercise, whereas others may require. So that's kind of the flexibility we have. And if you are familiar with AWS, you know that they have this sort of well-architected framework. There are 6 pillars, and they talk about a bunch of good practices, how you design and deploy and run and operate your solutions for various things. What we do is we take, because we are serverless, there's a paper called Serverless Lens. We have our own service audit. So what that means is, like, before any microservice that goes to production, the engineers must go through a bunch of checklists to make sure that they've taken into account all these aspects. Now, you may think that it's so difficult. No, it's not. It's difficult when they make a start. For example, structured logging. Okay, initially it's a struggle. Then every squad makes as part of their implementation. So that means it's just a tick box for later on. So many of these things kind of come in as part of the development, including some of the the security and data privacy aspects and things like that. So development, how do we develop? Okay. So I mentioned that we do a slightly different style of microservices. How many of you read domain-driven design? Quite a few. If you think this is a book, I would say it's not a book. There's a big industry behind it. Think of all the books that were written about DDD, still being written to make it understandable for you and me. Think of the DDD specific conferences where you pay thousands of dollars. Think of all the week-long training courses to teach you about. So it's good that Eric has written the book for the industry to grow, right? Because it's a huge thing. Now, I like DDD, but the problem is with modern engineers, it's a struggle, because it's written almost 20 years ago. And if you read that, you know that it's influenced by OO and plenty of UMLs. Not many engineers these days know any of these things, right? So that is a struggle. But it has all good things. It talks about the domain model. It talks about supple design. How can you have your design kind of sustainable, bounded context, anti-corruption, and all these sort of distillation of the core domain. That's where he talks about go down, deep down, distill it. So that's the principle I will talk about now, about what I call set-piece microservices. So if you look at the domain, it's more like looking at a forest, right? Because that's the whole view. But in a set piece, you are kind of going deeper. You are trying to see the trees or the woods. So that's sort of the granularity that I'm talking about when we build our microservices. Typically, any microservice book or article or talk, you hear 4 or 5 things: products, customers, orders, checkout, payments, right? Why don't they go deeper? Why don't they, kind of dismantle the customers and go deeper inside the customer domain and talk about smaller microservices. That now happens. So anyway, so that's basically the concept. So what I'm trying to convey here is like it's good that we need to have the whole understanding, but when we work, let's focus in parts. I like this conversation from the movie Mamma Mia, where they talk about some sort of life complicated things, and the man will say, oh, everything is complicated. And the woman who is more kind of optimistic, she would say that nothing is complicated if you break it down. So that is the core, theme of this set piece microservice I'm talking about. What is a set piece? Basically, if you think of filmmaking, just ignore the sort of linear and single shot stuff. Normal films, they don't shoot from the starting to the end, right? So they film in sequences, okay? Then they come somehow bring things together. Same thing, you go to a theater and the scenes changes. They do background or the curtain drops and things like that. So football, if you take football, this is where actually I took the term set piece. There is a term in English football called set piece play. That is when someone commits a foul, they aim at the goal and score a goal. Not necessarily they kind of, all 90 minutes they, play start to end. And same with when you build models. So you build in smaller parts and then bring together. So set pieces basically, you can kind of focus on these small parts. You can kind of practice them. You can rehearse them. That means you can test them before you take to production. So that's kind of, I heard the modularity talk earlier on, modularity in one of the talks. So this kind of coming into a sort of modularity thinking. So to give you an example, so payments, if you look at payments as a big domain or subdomain or however you have it, and as a big microservice, it's a monolithic single microservice, okay? One delivery pipeline, one unified complex view. So typically you will have your pipeline something like this. But question is, what if your authorization logics changes often? So you have to kind of, change that, like, the banks or the card providers, they keep changing. Why do you need to deploy everything else if only the authorization logic changes? So you can, take that outside, take that apart if possible, and have a smaller microservice. So that is the whole idea of this sort of set piece microservice. So for example, authorization comes out, and settlements, that is also known as capture, that's when the fund transfer, that's completely a background activity that happens after the the sale and things completed. So why do we need to put that as part of your main microservice? There's absolutely no need at all. So this is basically the thing. But one important point here is they all stay inside the boundary. That's very important. That is the domain boundary. So they all stay inside and do whatever they feel like doing inside. Right. So in terms of delivery pipeline, so can be deployed independently. So each service can have its own delivery pipeline. So you think of as a monorepo where you have these sort of multiple services sitting. So payments repository, and then you have the delivery pipeline. To give you another example, so here is the loyalty service platform that is currently being developed. It's also in production. I won't go through the details, but this is kind of a rough split of the internal microservices within the domain. So the rectangle outside is the sort of the domain boundary. So to give you a brief idea, so if you think of the last three microservices on the end, they interact with some third-party application, right? So for example, the SaaS CRM, the one we use is known for downtime often. So that means only that CRM mediator needs to worry about, how do I kind of retry, how do I buffer, how do I store these requests coming in. None of the other services will get affected. So there are a bunch of reasons why they kind of split this way, but this is not the the only way to go, but it's possible. Right, so how do they work together? Event-driven architecture, obviously. But if you think of the examples I show, how do they work together? So there's a music in a movie, right? So the background score, there's a dialogue that carries one scene to the other. So similarly, when we work with toys, we have interfaces. So if we switch over to microservices world, we have APIs, we have messages, we have events, and then we have these beautiful mechanisms like orchestration and choreography to help us. So couple of few seconds seconds on the orchestration choreography, just to give you an idea. Choreography, so typically choreography is kind of the dance movement, right? The point here is like once they learn how to, they make the moves and stuff, when the music is played, they just perform. There is nobody instructing them to do this way or that. So this is kind of, in a way associated with the event bus, where you have the publishers and subscribers. The subscribers, when they receive the messages or the events, they just do what they're supposed to be doing. So that's kind of the, the choreography mechanism. So usually choreography is used to bring all these different microservices together in operation. On the other hand, we have orchestration. Orchestration is like a typical orchestra. So you have somebody conducting, somebody instructing, okay? And this is typically associated with workflow. In workflow, we have a workflow engine that kind of tells each part to do what. There's a, sort of a wait state and all sorts of things happening there. And typically, my kind of recommendation is that use orchestration within your microservice so that you don't need to reach out to resources in a different service and have this sort of hard dependency and things. So there are a bunch of ways you can do. But the beauty is that when we have the choreography and the orchestration, that's when the beautiful event-driven architectures happen. So tech stack that we use, bunch of things, TypeScript, CDK, serverless, etc. This keeps changing now as we have more teams. Development cycle is simple, as I mentioned. So the culture is basically, if you build it, you run it, okay? Operating-wise, CI/CD pipelines, just kind of standard. So as I mentioned, GitHub Actions we use, and they have a bunch of tools. Each product squad has a control center. They know exactly which services are in which environment and how to push forward, etc. And as part of the monitoring observability, every squad needs to have enough alerts and alarms, and they get channeled to different, team channels and other emails and stuff like that. And monitoring dashboard, you will find tons of these things across different product, teams and stuff. Continuous improvement is another important aspect. So keeping up with serverless, I'll quickly run through. I think I'm kind of going over. Because serverless is a new way, we need to kind of change our way of thinking when we work with serverless. That's an important aspect. So like I mentioned, I heard earlier on in the the talk this morning about this sort of typical the legacy waterfall model. Those things gone. We don't do big bangs. We kind of small iteration. We don't get into the maintenance mode these days because we are kind of sustaining the application all the time. And we don't have siloed specialists. We have kind of full stack and the team. Right, okay. So because serverless is evolving, this is just AWS, it's the same with any cloud provider, we need to kind of come up with a way to keep it going. So one way of doing is like learning the process and refactoring, embrace refactoring. Refactoring is not like a legacy term that happens once in a while or only for Y2K. It happens every time in new technology. Right, continuous learning, I mean, I don't need to talk too much. It's a bunch of things around there, the community for everyone to learn. And then when it comes to refactoring, it's a bit tricky because getting the approval from stakeholders can be a bit difficult. So the olden days, the refactoring focused on program refactoring, but these days we have tons of other things to think about. Programming, one thing, infrastructure there, different services for cost, performance, sustainability, all these kind of things come into the, the picture. But refactoring in the sense that it's difficult to convince stakeholders, because if you talk to stakeholders saying that, we need to refactor this, but they say, hang on a second, I thought we were using cutting edge technology. What are you talking about, refactoring? So you need to make it understandable in their terms. So for example, you need to make sure if you are improving an API performance, you need to say that, okay, it's going to give us a good NPS score. Or if you're changing your buffering size, you need to say that, oh, now we can, help or serve more customers. These are the wordings that help, the stakeholders. And in terms of development, it's difficult, but try to negotiate and buy a sprint or two every quarter to get to these sort of refactoring or, tech debt removal activities. So there are a bunch of things, the reasons why we need to refactor. There are new services because it's always changing, growing, etc. Now, team-wise, growing the team, I do a complete separate talk on how to grow serverless teams, is because they need to be given their autonomous and the ability to grow. That's only then the innovation happens. If we constrain them too much, they suffer and nothing will come out. So gone are the old days where they need to follow the things, but nowadays, as you know, there are things happening all around, so we should be able to kind of, get on top of these things. So a number of things you can encourage within your organization: certification, having a channel. Morning I heard about the Video Friday, or the, those are the occasions where you bring your team together to talk about technology, watch somebody's talk and understand, etc. Takeaway points. I heard again similar thing earlier on. If you keep on thinking about something, you will never get this thing done. For experience, you need to undergo it. You can listen to my experience or somebody else's experience, but unless you go through it, you won't feel the experience at all. And so just to wrap up, if you're into serverless, if you're going to serverless, make a humble start and keep improving. Think granularity and make use of the power of granularity when you work with serverless. That really helps. And don't get bogged down by textbook style microservices things. You have the freedom, as long as you are within your boundaries, to go deeper and make it more easier for you. And the final thing is, if serverless technology, if that gives you the kind of the slingshot to gain more momentum and to get to your business velocity, speed and value, then please embrace it and use that. That's all for today. Thank you so much for your time. Thank you.